My name is Jeremiah Dooley. I am the senior manager of what we call the Next Generation Data Center Worldwide Pursuit Team. So my job is most people who know NetApp know of maybe one or two products that are in that portfolio. In order to give more attention and more focus to the entire portfolio, and particularly all of the scale-out technologies that we have around object storage and block storage, we built a business unit that's specifically designed to drive the adoption of those technologies inside our customers. So I run a pre-sales team that basically handles trying to introduce these new technologies, of which the SolidFire FlexPod is one of them, to our existing and to new customers, to kind of show them that the NetApp that they may have known from 5 or 6 years ago has a little bit more to offer today, and we do that by way of solutions and by way of the architectures that we're showing. So it was important to tee this up because the FlexPod is something that isn't, we didn't introduce the FlexPod today. And the FlexPod has been one of the primary converged infrastructures that we've used to deliver Cisco technologies to the market for a long time. And what we are doing is, for the first time, we're actually changing the fundamental architecture of the storage that's underneath it. We're also changing the consumption model from a hardware standpoint, right? So we're finally starting to introduce real software-defined storage into a converged infrastructure so that customers really and truly have one hardware platform, one hardware vendor, in this case from the network all the way down through the storage to be able to deal with. At a glance, we've got some pretty straightforward tech specs on what we're offering here. The version of ElementOS, important to note, we didn't have to create a special version of software to be able to run the storage platform here. It's the exact same version of ElementOS that we use for every other consumption model, that we use for every other appliance that we have out there. The benefit here, same functionality, same integration that we would have between SolidFire clusters, regardless of whether one of those clusters lives inside a FlexPod and one of those clusters lives in an environment that a customer has already purchased. So we're going to make sure to protect all of the functionality of ElementOS, regardless of how the customer purchased that. And then the rest of it is a pretty straightforward stack. So we're going to use the C220M4s for the storage nodes, and we'll talk a little bit more in depth about that. We're going to use the 9372s for the Nexus at the top of rack. However, NetApp and Cisco will support any of the Nexus switches at the top of rack, so anything that is normally supported in the FlexPod spec, whether we're using 3s, 5s, 9s, anything that we want to use up there is going to be supported as part of that. And then for the fabric interconnects, we don't have to use the newest version of those fabric interconnects. So for customers who have previous versions deployed that want to be able to roll them into this spec and be able to drive the FlexPod support for it, we'll still be able to offer that. The vSphere version, the 6.5, is important because we get some additional capabilities from a VASA perspective, specifically around how we handle the storage and the vVols and some of the functionality there. The rest of it, what we've tried to do is stay as true as we can to the architecture that we've used for the FlexPods for the last 6 years. Right? We want to be able to offer more features and functionality and address different use cases, but we didn't want to reinvent the wheel with how it is that we're creating VPCs and how it is that we're attaching things to the fabric interconnects. And don't worry about squinting at this. I've got so many more topology diagrams that will dig into every possible configuration that we can look through. Where I wanted to start, though, is the completely net new part of the platform. In every other converged infrastructure and every other converged infrastructure that Cisco handles with any storage vendor, the storage vendor provides the hardware, right? So regardless of who it is, even NetApp for the existing FlexPods, we've got Cisco top rack switches, we've got Cisco fabric interconnects, we've got Cisco B-Series and C-Series servers. We've got all of the Cisco pieces in there, and then we've got a storage appliance that gets provided, has a different form factor, that has different capabilities, different types of ports that connect into it. What we did here is, because the power of ElementOS is the software and the hardware really is just out of the box, we delivered the entire thing on top of the Cisco platform. This really helps streamline things from a support perspective, but it also gives us the ability to tie directly to the updates that Cisco is making across the M4s to the M5s and really be able to tap into their roadmap around the compute side. It gives us some interesting possibilities down the road around the personalities of the rack mount servers, right? What really determines a storage node from a compute node? And I think that once we get this model in place, I think the definitions between those as both the storage software and the hardware chipsets mature to blur that line a little bit. So we're driving 8 1 terabyte SSDs in this. For those of you who know, the standard SolidFire appliances normally have 10. This is another one of those things where ElementOS doesn't care how many drives are in there, right? If we were doing 10, if we were doing 8, if we were doing 6, it doesn't really matter at all. Still rolls up as performancing capacity into a single pool that ends up getting spread across all of the nodes. We do a minimum of 4 nodes. We've got 2 10 gig E connections out the back of each of them that connect to the Nexus switches at the top of rack. And we're driving 75,000 IOPS per node with 7.6 terabytes of raw capacity per node. We support a minimum of 4. So in order to build that initial cluster and make sure that we've got the ability to do rolling upgrades and that we've got the ability to elect a cluster master, we have a minimum of 4. And we'll do a maximum of 40 in the first version of this CVD. So the scalability, the ability for customers to buy what they need now, scale that out, but then most importantly have a very consistent, very reliable, well-documented network topology that's going to plug into in the background. You'll notice we're also simplifying this because there's no fiber channel. There's no fiber channel connectivity to the storage array. There's no MDS switches. We've made this a 100% Ethernet topology on the back end, which fits really well with the SolidFire architecture and with how we present that out. This has been an interesting evolution for us because the marketplace is has a very fixed way of looking at C220 compute nodes, right? For a C220 compute node, we plug those into the Fabric Interconnect. We manage those through UCSM. UCSM does fun things like update firmware on SSDs, right? It does things that we are very comfortable with from a compute standpoint that don't necessarily translate well to the storage side of things. Even all the way down to, we all know the FIs aren't switches, right? I can't do active-active across them. I can't build a VPC across them. There are things that in a storage environment where I need to be pushing active-active bandwidth out of every one of those nodes, that running that to the top of rack switches ends up being a much more scalable, much easier to manage design. So the difference between a C220 M4 compute node and a SolidFire storage appliance that's built on the C220, in addition to the cache mechanism that we put in there, we're trying real hard to draw that line. Right? There will come a time at some point in the future where it's easy to field upgrade something and turn it from a compute node into a storage node. That day is not today. And so we wanted to be real clear with everybody that it's still managed via the SolidFire API, not via UCSM, that ElementOS takes care of the firmware and the drivers and all of the pieces that are in there, that it is a storage appliance and that it's not integrated into UCS Manager, does not connect into the Fabric interconnects for any number of reasons, and that over time we'll see whether or not the architecture of SolidFire and the capabilities of the Fabric interconnects and UCS Manager converge. But today, UCSD, the UCS director, works perfectly for doing all of the orchestration and automation that we need.
Is the drives the only thing that's physically different in the box, or is there different hardware inside?
No, so the drives are identical. These are 100%, we buy them from Cisco. They're Cisco drives, okay. Cisco certified. The only thing that we put in there is the 8 gig Radeon cache card, right? And for those of you who have kind of been following along with SolidFire, at some point we get persistent RAM. That means we don't need the 8 gig Radeon cache card in there anymore. And the hardware portfolio at that point for us opens up a lot more, because then Intel's helping us instead of requiring the Radeon add-on there. So this is a 100% out-of-the-box C220 with the addition of the Radeon card. Our big challenge with UCSM was the drive firmwares, right? I mean, when UCSM gets the notice that there's a drive firmware upgrade, that's great. ElementOS doesn't like people changing drive firmware underneath it, which understandable. We're able to use the vendor drive firmware, so we're not creating our own drive firmware or anything for that, but we like to be in charge of what version of firmware we're running and what we're doing and those sorts of things. So it just easier, and they're storage appliances, right? They're not compute nodes, they're not, it's not running workloads, they are running ElementOS, so it just made it easier to draw that logical line between these are compute nodes and these are storage appliances. And someday we may be able to move back and forth between them, but for today, that's a pretty clear line in the sand. All right, so topology-wise, it's pretty straightforward. The big question that we get is around the connectivity of the nodes into the rest of the environment. Right, so we're pretty straightforward. We've got the FEXs inside the 5108 chassis. Right, we've got the connections up into the fabric interconnects. The fabric interconnects have the cross VPCs built up into the Nexus top-of-rack switches. From that point, we're going to build individual VPCs from each of the SolidFire nodes so that we've got 20 gigs of aggregate bandwidth per node that are all being aggregated into one cluster from a performance and capacity standpoint. So we're going to deliver a minimum of 80 gigs of bandwidth for the smallest possible FlexPod that we can drive out there. So that's 80 gigs of bandwidth. That's 300,000 IOPS worth of performance, and then the effective capacity that customers are going to get based on whatever dedupe and compression they put on top of the raw capacity that's being delivered in there. We drew these out, and there's a couple of them here that we'll go through. When we talked with customers, customers asked us, how do I do a 10 gig E end-to-end? How do I do a 40 gig E end-to-end? And then if I've got other outside servers, right? In this case, we're going to focus on the C220s, but if I've got other outside rack mount servers, how would I integrate those in? And so for the 10 gig E, it's pretty straightforward, right? Again, if there's anything other than the B series in there, those would be connected directly into the fabric interconnect. So even though they're identical servers, we've got kind of two different classes of what we would be able to do there. So again, the 10 gig E side of things, and then when we jump over to the 40 gig, now really what we're changing is the top rack switches, right? We're changing the model of the Nexus 9000s. And again, because the storage cluster works off the concept of the aggregated bandwidth of all of the nodes, and we're load balancing the volumes and the performance of those volumes across all of the nodes that are in there, that 80 gigs, if for whatever reason we needed 100 gigs of bandwidth, we'd simply add another node. We plug it into the two top-of-rack 9K switches, right, build the VPC to be able to manage those as active-active, and away we go. So we can allow customers to scale the bandwidth to the compute side. We can allow customers to scale independently the bandwidth that comes out of the storage side, and we're not necessarily burning ports on the fabric interconnect to be able to do that. So again, with the 40 gig, anything external to that would plug into the fabric interconnect. And the UCS Mini works essentially the same way. It's fun because 2 years ago at Cisco Live, before SolidFire got acquired by NetApp, we built a reference architecture that was Red Hat OSP on a Cisco UCS Mini with SolidFire nodes in there. In fact, Chad, who's here in the room with us, he and I ended up putting that together and building that and going through all of our learning pains on how to do iSCSI boot from SAN on the UCS platform. But being able to do that as well. So again, no external fabric interconnects. We've got those internal to the chassis. We've got the top-of-rack 9K switches, but predictable, depending on what type of product or what type of form factor here it is that you're using. When we look at the port counts, we did all of these pretty diagrams, and then of course the first question that we get is, so logically that's great. Physically, what do those ports look like? And we wanted to call out the difference between the 10 gig unified traffic that's up at the edge going into the fabric interconnects, the 10 gig iSCSI and LAN traffic that's going between the fabric interconnects and the Nexus switches, and then the iSCSI only traffic that's going from the Nexus switches down to the individual storage nodes. And again, the simplicity of only having two data connections to each of those nodes rather than having fiber connections and Ethernet connections and management port connections and all the rest of the things that we need in there means that the network topology, the number of ports that you need to use, we tried to be as efficient as we could while still allowing to scale out as many of those storage nodes as we need to. When we talk with customers about that move from a regular dual controller storage array over into a scale out kind of node-based architecture, one of the questions that we get is around iSCSI. Why did we use iSCSI? Why do we use iSCSI instead of fiber channel? And the easiest answer, kind of the primary answer there, is going to be the concept of an iSCSI redirect. Does anybody know what an iSCSI redirect is? Andy, you don't count? All right, so one of the things that you have a challenge with when you build a distributed storage product across nodes is the idea of where is the data and which node do I go to get it. And in this environment where we can have load balancing that is moving volumes from node to node, where we've got random placement of data that comes in across all of the nodes so that we can leverage all of the bandwidth and the CPU and RAM of each of those in order to be able to make sure the performance stays consistent, the question that you have is not just where do I go to get my data, but what happens when where my data is changes. And iSCSI is perfect for this, and it's why even 5-6 years ago with the EqualLogics of the world, it's why iSCSI was the platform that was used for those node-based scale-out architectures, is because iSCSI already has this built in. We don't have to add anything, we don't have to extend a spec, we don't have to do anything custom. We can just take advantage of the iSCSI redirect protocol. And the redirect protocol lets us create a virtual IP for the entire cluster. So no matter how many nodes are in the cluster, we've got one management IP and we've got one storage IP. When a request comes in, and we look at kind of path A here, or path number 1 here, the request comes in and a host, so an external host, it could be a VMware host, it could be an OpenStack host, it could be an Oracle server, it could be whatever. It goes to log in to the SVIP and it says, I need volume DS2. Where do I go to get it? And the iSCSI redirect protocol says, you go get it here. The next time you ask for that, don't come to me. Go directly to the node that owns it. And in the SolidFire case, it would be the node that owns the metadata, and the metadata knows where all of the blocks are distributed across all of the nodes. So this happens real time all the time. If the load balancing algorithm moves the primary copy of a metadata, or a node failure moves the primary copy of the metadata from one volume or from one node to another, the next time that host goes to connect, right, it'll time out. That timeout will go back to the storage VIP, and the storage VIP will say, okay, that volume now belongs here. That's how we can allow customers to scale out. That's how we can allow load balancing to be a natural part of what's in the back end there. It's also how we can make the networking side of that really simple, right? We can do multipathing, we can do load balancing, we can do all of that from a single IP, because that single IP is actually being leveraged across all of the interfaces and all of the paths that we have between the host at one end and the storage node, the storage cluster on the other end. Does that make sense? It's, from a network standpoint, it's fascinating because it's the easiest way to get away from that. I have an A controller and a B controller, right, which is what the fabric interconnects were designed to recognize as storage ports, right, into this distributed architecture that says the data could be anywhere. And I'm not going to tell you where the data is until you ask for the data, because I may be moving that data around constantly in order to be able to take into account new volumes that were created, new nodes that were added, nodes that have failed, things that I need to do on the back end in order to maintain the integrity of that cluster.
Now you said if it moves, it times out.
Yes.
And then it falls back to the VIP and the VIP response.
Yes.
What's that timeout like? I mean, and does that impact access speeds when you have to deal with that timeout of something? Sure. Where to migrate?
So yes, and it would be in the case of, let's say, a node failure, right? The metadata for a set of volumes was located on that node. That request is going to come in. That timeout process works tactically the same way it would for any path down environment, any path down situation with any type of storage array.
Okay.
Right? The host itself is going to have a how long do I try before I mark that disk as dead.
So this is all host-based. This isn't necessarily in the system itself.
Right. So
okay.
so there are libraries of best practices that say for this host, this is the default for where the timeout is before it marks the volume as dead. Right, bad stuff happens, and our job is to make sure that that entire failover process happens underneath that timeout. The same way we would for a fiber channel storage array, the same way we would for an InfiniBand storage array, anything that we wanted to do.
Okay.
So as long as the best practices have been followed such that that timeout process, which we're talking seconds at most, that timeout process is less than what the host is expecting and is normal for the operation of the host, there's no impact to the end users whatsoever.
Okay.
And that's not something that happens all the time.
Right,
Even
it would
the load
be a
balancing
failure
on the
condition,
back end,
yeah.
well, or adding more capacity to the cluster.
Okay.
When you add a new node in, we're going to use that node to load balance the stuff all the way across. And
So data
when we do
migrates.
that, we're going to find volumes that it makes sense to move that across. So that's not something that we're going to do to excess, because there is a process there. And if the customer didn't set the host up the right way, they're still going to call and yell at me, right? So we try to be as gentle as we can there, but the good news is that iSCSI redirect makes that entire thing, we don't have to invent it, right? We just have to take advantage of what the spec already has for us.
Thanks.
Yep.
So is what is this ISNS or is that something different?
That's something different.
Oh, okay.
Yeah, this is just
just
pure
iSCSI
pure
redirect.
iSCSI, out of the box, straight off the RFC, pure iSCSI.
Okay.
No changes, no extensions, nothing customized.
So when you're configuring the initiator, you're pointing everything at the SVIP,
One
and then
IP.
it just magic happens
Yep.
because that's the
Yep,
protocol.
and again, we can do lots of stuff on the host side. So if we were doing VMware, we could create two different storage ports, right? Two different storage ports, and then load balance across them at the host level, right? So we could have two individual paths, or I can VPC them so there's just one path and let Cisco do all the magic of how many paths do I have from point A to point B and what happens when one path goes down, right? We much prefer Cisco handle all of the pathing and aggregation between it, because the network always knows what to do in a path down situation faster than either of the devices on either end would, right? So, and that again is one of the 20,000 reasons that we don't plug into the Fabric Interconnect, because it's not a switch and we have to do the detection of, is that path down? How long do we take? What does that mean to the timeout on the hosts, right? So we like having a nice, easy VPC built, plug it into something that Cisco runs, and then let it handle all of the pathing, however many paths we wanted to have. By default, there's two NICs per node, and then multiply that by the number of nodes in the cluster. And so there's lots of bandwidth for us to be able to use for that. Does that make sense?
I think so.
Okay. All right. One of the things that when we talk to customers, that intersection between storage and compute is pretty straightforward, except for one place, and that's where do we boot the compute nodes themselves off of. And part of the reason all of us love the Cisco compute is because this idea of stateless matters to operations people, right? Back in the day when we had HBAs plugged into nodes and we had PCIe NICs plugged into nodes, and everything was zoned based on WWPN that was physically attached to the HBA, and we had MAC addresses that were physically attached to the NICs. If I had, for instance, a VMware host die, I would pull the cards out of the old host and put them into the new host, because then I didn't have to go back and rezone anything. Then I didn't have to go back and redo any of the policy mapping or anything that I'd done that was based off of a physical hardware address. UCS takes that off of us because all of that is set by software, right? But if I'm still physically booting off of something that's inside those nodes, now I've got something that's not stateless. Right, now I've got shared storage, and I've got pooled compute, and I've got redundant network. But as soon as I put disks in those nodes, now I've got something that belongs to that physical node that I'm going to have to manage from an operational standpoint. Boot from SAN has been around for a long time. Before I came to SolidFire, spent 3.5 years at VCE, and we did boot from Fiber Channel for every vBlock that had ever been shipped, right? And the FlexPod by default will do boot from SAN as well. This is the first time collectively that anyone has tried to formalize boot from iSCSI out of a node-based architecture, right? So not just booting off of a dual controller where everything's pretty straightforward, but something where that boot volume could live on any node. And we're going to leverage the same SVIP that we do for the host connectivity for the iSCSI boot. And so when Chad and I first did this probably 2 years ago, I think we opened maybe 8 trouble tickets with the UCS team, between UCS manager interface issues, and it just wasn't, they built the support for it. And I don't know if nobody used it and figured out where all of the things that didn't work in there were. But we spent a lot of time as SolidFire and then as NetApp making sure that that process was something that we could do repeatedly, that we could do straightforward, and obviously booting the compute nodes is something that can't just work some of the time. So when we talk about this, the other part of it that is interesting for us is that we have the ability to leverage both sides of the network fabric in order to be able to do that. We're not limited in like we would be in a dual controller environment where we've got one of those active and one of those passive. We're not limited to a single path. So we can survive a path failure even during a boot from SAN and be able to continue on as if nothing happened. And so we can really take advantage of that network topology upstream. So being able to match the initiators, the software initiators that are created by policy in UCS Manager with a boot volume, right? Being able to target, be able to build the target to do a volume access group that says this group of hosts is allowed to boot off of this set of volumes that are being created on the storage side, and then being able to leverage that single SVIP for all of them. So that from a practical standpoint, every host boots off of the exact same SVIP over the exact same path and gets mapped to its individual boot volume, which if I fail a node, if I fail a compute node burns up, compute node dies, whatever happens, all I have to do is put that new compute node in, push that UCS policy back down, and I have the exact same host that's going to go boot off of that exact same path and that exact same target. Right? So what we can do here is we can really focus on leveraging all of the stuff that's in there, and we're not compromising any of the network connectivity. We're not compromising the ability to boot the hosts simply because we chose to use iSCSI or we chose to use a node-based architecture. If we can do that, this really takes a lot of the, do we boot across the network? Do we put SD cards in each of the UCS servers to be able to boot off of? We can take a lot of that, which part and how far do I want to compromise my stateless data center environment by saying, don't do that at all. Right? Use your UCS manager profiles, build it the way that you would normally build it, and we'll behave the way that you expect us to, with an architecture that is different and with a boot process that is different, but still ends up being, ends up delivering the necessary effect at the end of the day. Any questions about the boot from SAN? This is one, we've had 3 customers on the floor. When we started going through the design with them, they immediately said, we've tried to do boot from iSCSI off of NetApp before, and it sucked a lot, right? And we had to be like, okay, fair enough. Dual controller arrays, completely different model of how we would build this here, right? This is something that we've specifically built into the platform. So this is one of those, it took, weeks of trying to figure out why a chat password wouldn't work in a UCS manager profile. There was a lot of work putting in to make this as boring as we could possibly make it, which seems like that's how hardware goes most days here. So we're really happy that this works the way it does, and I think that this kind of rounds off the final value piece that we need to put in order to make that end-to-end stateless, end-to-end IP environment viable. So the last real slides, again, we're going to talk about that max of 40 of the 9608 nodes. And for those of you, you may never see or talk SolidFire again, but the model numbers, the engineering team hates them because it makes them hard to manage. The customers love them because it makes it easier to figure out what they're doing. The 960 is the size of the drives in there. 8 is the number of tens of thousands of IOPS that we're driving out of the node. Right? So when you see any of the SolidFire part numbers, it's very obvious that an engineer was in there building out part numbers and not anybody from marketing involved with it. The SSDs on the 9608 are not self-encrypting. And we've had a lot of conversations on the floor. We get these drives directly from Cisco. Right? So these 960 Samsung drives are not self-encrypting. And what we're finding is that more and more the self-encrypting drive model is going away. And it's interesting to debate why and what we were actually protecting with self-encrypting drives anyway. But the point here being there are not self-encrypting drives. The firmware that comes from Samsung does not have self-encrypting drives in it. The standard NetApp SolidFire appliances do have self-encrypting drives with it. So that's one of those selection criteria of would we go standalone and build our own stack, or would we use FlexPod to be able to sell it. The boot from SAN is supported. There are some caveats in there. It's hard to template the boot from SAN profiles for the individual nodes. We got around to this and made Cisco happy at the same time, which is not the world's easiest thing to do by using UCSD to automate it. So by building a workflow that takes into account what we're trying to do, it means that we don't have to build those profiles directly into UCSM. UCSD, right now, we can do the bare metal side of it. We can't do VMware because UCSD isn't certified on 6.5. As soon as that happens, we will roll that in, and UCS Director will be the single source of truth for the entire stack level orchestration. And again, just to reiterate, you can't take a C220 that you already own and magically wave a wand at it and turn it into a storage appliance. I know everybody would love to be able to do that. Trust me, it's way high up on my, my Christmas wish list. We will get there as soon as we can, but right now, the SF9608 is a standalone storage appliance, and there's no movement back and forth between the two of them.